Hello everyone, today I'll deliver a lecture on wind load calculation, especially for steel shaped building or low rise building as per ASCE-7-05 and BNBC 2020. Here is a BNBC 2020 as a ASCE-7-05 minimum design load for building and other structure. And another one we can see Bangladesh National Building Code, which is BNBC 2020. Okay, let's start. Okay, so let's see. Here is a calculation, wind load calculation for steel shed building following ASCE-7-05 or BNBC 2020. So let's start. I will start. We can see here the steel shed building information is the location in Dhaka. Occupancy category is 2. How it get? It is taken from code, as we know. Here's the method 2. This is the procedure. Sorry, before I'm going to the apply. I'm explaining how we'll apply this. So I'm going to ASCE-7-05. So here we have been using main reinforced resisting system, and we'll use the analytical procedure. And we can use basic wind speed and special wind region, where it is region Dhaka, and wind directionality factor, importance factor, exposure, wind directional sector, and surface category. If surface category B, C, D, and roughness, it will be depend on. And topography factor Z and Gust factor G. It is generally taken 0.85 as we know, as we all know. And the velocity pressure we have been seen. If it is taken from the pound per feet, then we will use 0.0025, and if we calculate in Newton per meter, then we will use 0.613. And we've been seen for rigid building all heights we can use this, but we are using the steel building, shed building, then that's why we will using this low rise building or steel shed building here. So let's see how we'll complete the task. So we've been seen here occupancy category 2. How we'll get? If we go to the BNBC 2020 page 3160, this is the occupancy category of building. Occupancy 1 category for agriculture, and 2 for residential and others building, and 3 for more than 30 people or school or power generation and oasis, and 4 for essential facilities such as hospital and healthcare and earthquake prone and hurricane prone zone and power generation. So as we've been seeing, this is the residential or others building, so it will be type 2. Okay, so type 2 have been completed. So importance factor have been taken 1. How will get? It will be taken 3182. So 3182, if we go to 3182, 3182, sorry, I'm just interrupting. 3182, if we go to the 3182, then okay, here is the importance factor for wind. We've been seen very clearly. It is taken the importance factor I for wind, as we've been selected 2 from 3061. Here we have been taken from here the wall buildings. It is type 2. Now the non-cycle prone zones, and that's why we have been taking the importance factor is 1. So that's why we have been selecting 1. Basic wind speed, we have been taken the Dhaka, so it will be 65.5. It is taken from 3182. If we go to the 3182 page, so 3182, sorry, it will be not 3182, 3181. Okay, it will be before here. And this is the 3110 basic wind speed b. For Dhaka we've been seeing 65.7 and 1 meter per second into 2.2365 mile per hour. So we have calculating here and found 65.7 meter per second as we are looking we're staying in Dhaka. And we have been using a main wind resisting force system and method. We have been procedure method 2. Okay, so now we can see the wind directionality factor KD, which is a 3184 base, 3184. If you go to the 3184 here, here we have been using wind directionality factor KD as we have been using building. So that's why we have been resisting system. We have been use KD value of KD is 0.85. Okay, so now we'll go to the topography factor KZ, which is 3134. So if we go to the 3134 here, we have been seeing the topography factor is 1 as we have been given here, and Gust effect factor 0.85. Okay, so we have been seeing use exposure category B 31 as per 3132. So now we'll go to 3132. Okay, this is the exposure category. So surface roughness category, if it is urban and suburban, then it will be surface category 1. If this surface is open terrain, that will be surface B, and if it's flatted and unobstructed area or water surface outside the cyclone, then it will be C. So in this we have been selected B because it is the open area in our country. Okay, now this is our steel shaped building we have been seen here. The length is 125 feet and width is 55 feet. So we can see this is the eve height. How we'll get how we'll got this is eve height. This is the eve height, and the maximum height is called ridge height. This is the ridge height. And if to ridge distance, we have been just deducting this value and found 2.7. And main roof height, if we want to see in our slide, so I'm just okay, I'm just going, yeah, this is also taken from online sources, which is decode video. So this is the eve height. We can see this is the eve height, and this is the ridge. The maximum height, and main height is also given here. Okay, so main height, we can see the eve height is 25, and the eve to ridge height is 2.5 divided by 2. Then we will go the main height. This is the main height. Okay, and the theta we have been, how we'll get, as you know, length into height into length. As we know, the height 2.75 is found, and length is 55 divided by 2. As we have been known, all the 55 distance is given here, and it will be angle 5.771. Okay, so let's see here the slope of velocity QZ. We've been the velocity pressure at any height jet above the ground we've been used here 0.00610, as we've been seeing here in ASCE-7-05. It's clearly given. This is the formula. If you use pound per feet, then we can use there, and if you use Newton per meter and B is meter per second, then we can use this formula. Okay, so we have been taking this value. If we go to the also BNBC, then we can also here 3137 3137. Okay, I'm just 3136. This is the formula is taken from BNBC 2020 as kilonewton per meter. On the other hand, this is a Newton meter, but if we convert kilonewton, that it will be triple zero is in front of, yeah, that's a kilonewton per meter. Okay, so kz we have been seen, velocity, pressure, exposure coefficient we have been taken also. Topography factor we have been also taken, but it will be 3134 page. And KD unit wind directionality factor we have been taken 3184 page, and basic wind pressure we have been taken from Dhaka zone, as we have been taken here 3137, and all the factors also wind directionality and topography factor also taken here. Many importance factor also taken here. So now KZ exposure category, it will change on the depend. It is depend on the category. So you can see here the lots of value is given with respect to KZ. We'll use this the interpolated value if 7.62 and mean 8.06 and reach 8.06. So the velocity pressure we have been seeing this formula, but we have been used KZ for eve height. As we know, eve height is 7.62. This is the 7.62, and the KZ will be 0.94. We have been used KZ in for mean value. As we have been seeing here, this is the eve height. This is the eve height. As we have been found 7.62. That's why we will use KZ 0.94, and mean height we have been seeing 8.04, and it will be used 0.94, and reach height 8.64 and found 0.95 we have been used. And in this way we can see all the value have been found. So now design wind pressure. Design wind pressure for the main wind force resisting system, which is called MWFRS of building of the height. We are seeing here the formula is given here. We have been already seeing the formula is given 3138 page. This is the 3138 page. We have been seeing this is not for steel, this is for wall height, but we are going to the specifically low rise building. So this is the our formula. Qz is velocity pressure, and evaluated at mean of the height exposure. And we have been seeing here another is GCF, which is external pressure, and another is internal pressure. So how we'll get what is the internal, what is the external pressure? So if you go here, sorry, I'm going to go to the okay, this is the air, this is the flow, this is the wind is going here. If you consider is the wind is going there, that's why the pressure will be internal, and the other section, this section will be external. This section will be internal pressure, but we can say suction, and this is the outlet pressure, this is the suction outlet pressure. So this is the, we can see internal pressure, external pressure, which is flowing from in this direction, and this also the external pressure. So we can, if we want to see here the positive with external pressure, this is the wind is coming here. The case one, the shaded building is buoyant, and external pressure is dropping here red color, and internal pressure we've been seen in the blue color. So this is not practically, this is we practically uses the diagram. The wind is coming here, so the red color is external force, and internal force is other leeward. This is the windward, and this is the leeward in internal forces, and this is the rooftop views. We can see here the wind is coming here and going to this direction. I also explain this is taken from Decode BD. I must be reference them. This is the windward. We can see windward, and this is the leeward, the opposite side of leeward, and this is the outside. We can see if pressure is gone there. So wind pressure is if gone there, then that will be outside. There's the side wall also. Okay, let's start. This is the pressure we've been seeing internal. Now we've been understanding what is the internal pressure and what is the external pressure. I've been said again and again. So this form of this diagram you have to you have to understand the right portion is external force, and the yellow marker is internal forces. So external force must be positive, and internal force must be negative. You have to memorize that. Okay. Let's see. So GCpi internal pressure is coefficient is figure given 3150 3151, or figure is given 3151. If you go to the 3151 slide number, so sorry for interrupting. 3151. So here is a 3151. We have been seeing here. 6.2.5 figure, 6.2.5 figure. Okay. It is not given here. Okay. So we have been seeing here the wind is going here. So this is the windward and this is the leeward. So this is the external pressure and these are the internal pressure. Okay, these are the external pressure, these are the internal pressure. Yes, all the given here. Okay. So as we have been found partially enclosed, then we will use 0.55 as given 3151 case. 0.55 the partially enclosed building, so we have been use 0.55. So positive and negative sign is pressure acting toward F. We have been already discussed. This is the toward, and so it will be positive, and the minus sign, and it will be away from the internal surface. This is the internal surface or suction. Okay, so let's continue. The Gust factor we have been found 0.85 and CP value we have been found from 3152 page. So if you go to the 3152 page, here, sorry, this is the here. So wall pressure is given here, the windward wall. So we have been seeing this is the windward wall. So the wall value L by D, which is given length and breadth, and CP value is 0.8. When the leeward wall, so we've been seeing this is the leeward wall, and wind is acting here, this will be leeward. So this is the wind wall, this is the lee wall, this is the wind wall, this is the lee wall. So if these are the wind, if the wind is coming here, this will be wind side, this will be leeward side. Okay, so leeward side is given is variation L by D, and CP value will be a variation here, and side wall always 0.75 CP value. Okay, so we've been taking windward 0.8 and side wall 0.7 always. So it will be changed only leeward and roof coefficient. So we've been taking this already shown the rigid. It will be shaded building, not rigid. I'm just eating steel shed. It will be low rise building or steel shed. Low rise. Okay, it will be low rise building or steel shed. I am just using the steel shed. That's why we have been using here. So wind to normal direction. So you have been seen wind, and normal, that means the perpendicular. Normal is always perpendicular. Perpendicular to this is the wrist, so it will be acting like this. So when parallel to this, we have been seen wind is going to the parallel or along with the wrist. That we can call when parallel to wrist. So B is horizontal dimension and normal to the wrist. We've been seeing this is the B, and L is the horizontal dimension means parallel to the east. This is the parallel to east, and h is the mean height. We've been seen here the mean height, and theta angle of the plane of the roof, horizontal theta. When theta is greater than 10, then h will be the mean height, is given page 3148. When theta is less than 10 degree, then h will be the eve height. So 3148, if we go 3148 page 3152 48 page, then we have been found okay, these are the given here. H is the mean height in feet, except the eve height shall be used roof is angle less than 10, and angle of the roof is horizontal is degree, so it is given here. Now we'll calculate the wind design wind load calculation. Wind to reach, no, wind load normal to reach. These are the wind, and it is the perpendicular or normal to reach. So angle we have been found 5.71, which is less than 10. So eve height will be used as is given here. So eve height we will use the eve height. So L by D we have been found 4.4. So be perpendicular to wind. So it is given 31, and L by H by L we have been found 4.44. So velocity pressure R of eve height we have been found 2.1114 kilonewton per meter square. So how we'll get this? If we calculating in previously, if we go to the here, then we can found all the value is this is the value 2. Eve height we have been already calculating, and 2.114 kilonewton per meter square. So we are just using this value for 2.114 kilonewton per meter square. Okay, so this is the note external pressure, which is positive. This is the external pressure, and internal pressure it will be negative. So this is the windward, this is the wind wall, and this is the leeward wall. This is the windward wall, and this is the leeward, and this is the side wall. This is the side wall, and this rope is windward roof, and this wall the leeward roof. So windward roof, now we are seeing windward roof, as I am already mentioning here. So I'm saying I'm just saying I'm just showing again and again. So this is the windward. So this portion will be windward, or you can see this portion will be windward. So we'll see the windward load. I will calculate the windward load. So windward we've been seen here using this formula, and found 2875. So now we will go to the our stat flow, or or others. Okay, if we select this member, then we will use this value. This is the windward. We have been using positive x. This is the windward. So we are using this formula, and found external pressure we have been seen 2.785, and using this formula. And if we this is the kilonewton per meter square. So if we but it is given kilonewton per meter. But if we give the tributary length, then we will found the kilonewton per meter. We have to multiply with tributary length. Okay, so or bay distance, it can call bay distance. What is the bay distance? This is the this portion half, and this portion half will be bay distance. Okay, so we have been found 2.875, as we are not giving 2.8, we are applying 2.8 here. This is the given here. So leeward wall, how is leeward wall, and this is the opposite side of the leeward wall. So if we go to the here, the where is leeward, uh, this is the leeward we've been seeing here, and the yellow portion is given leeward. So leeward we've been using the all the parameter is given here, and cp we've been use sorry cp we've been use 0.50. How will why why we have been use 0.50 cp value, why we have been used the windward cp is 0.80, because we have to go to the cp value where, okay, I'm just sorry for interrupting. Okay, this is the cp value we have been seen here. For windward we have been used the cp value 0.8. So these are the cp value 0.8 we have been used, and the leeward we have been seen 0.50 we have been used 0.50 minus 0.50, not 50. So that's why we have been used minus 50, and we have found this value, and we are using this value in leeward or this side. And sidewall, and consequently we've been using this formula and sidewall, which will be change the cp value, as we've been seen here. The cp value for sidewall is always 0.70. So we have been used always 70, and the value will be this like this. If we apply this value here, so it just sorry okay, you just select this value. I'm just randomly seeing here to 4.1, but it will be 2.516. If we want to apply here 2.516, you just multiply with the bay distance, as we've been seeing the bay distance. Then the sidewall bay distance, if we use the bay distance, then it will be the force will be converted in kip per feet. Okay, and then now we'll go to the rope pressure of cp. We've been given 3151, page 3153. So now we'll go to 3153. This is the rope coefficient. We've been seeing the normal to that is less than 10. So our height we've been found theta 5.71. So it is less than 10. So now we can see the normal to reach will be use this type of, as h by l we have been found also less than 0.5, and horizontal distance from the wind to the edge, say for 0 to h2. Okay, so 0 to h2 divided by 2, h divided by 2. So our h was 7.62. How we'll get 7.62 is we have been taken here is 7.62. We have already shown here is a given value 7.62. 7.62 is given here, where yeah, this is the eve height 7.62. You can see 7.62. So 7.62 meter is eve height is given here. Okay, so after the find 7.62 divided by 2, which is 3.81. So we have to use cp 0.90. We will use 0 to h, which is 3 to 3.5. So this value we are dividing here. Sorry, where okay, this value might be h divided by 0 to h divided by 2. We'll use this value cp 0.902 is given 0.9 and 0.80, and another h2 into h. How this will mapping is divided by h, as we've been using at rope, and the cp value will be 0.928. 0.928, this value will be used. and we've been seeing H to H, so it will be H to H in in the here H to H, and another one greater than H, then it will be CP value is here. So mainly I have been shown here the value of C2 will be changed, so that's why I'm changing here CP value. So windward roof in right side, so we are going to the right side, and CP is 0.90. 0.90 is here, or 0 to H we have been use 0 to H. Okay, and we have been found windward roof. What does mean? What this is the windward roof. So we have been found windward roof when CP below 0.9, when positive GCpi point we have been found minus 2.708, and when minus GCpi, as we have been know the positive and negative GCpi value is point negative and positive is given here. So we have to consider this 0.80, 0.90 and 0.90 also. So and this and in this way CP value is 0.90, but GCPS plus minus 0.50. So these are the plus minus. So here is the plus minus GCPI value. We've been seeing the plus sign is toward, and minus slab is away from what is internal surface. Toward an internal surface, I am already says here. This is the toward, so it will be external or toward, and this is the internal surface or negative value. Okay, toward the negative value. This is the minus side. So let's see here. That's why you have been using these two type of value. Have been found 0.50 and found toward negative value, and we have been seeing this negative value and this negative value in windward roof. Now we'll go to the windward roof. This is the windward roof, and we have been we've been found two type of negative value. So windward roof we can use the positive negative and positive value, which is the toward, and also toward the negative word. So that's why we are seeing the internal pressure is negative. And another one we've been used 0.8 point enclosed building point 0.18. I will get the 0.18. This is the CP value is 0.1, so not GCPI. GCPS 0.50 is remain same, but the CP value is changed 0.10. So if we go to the here 0.10, sorry, I'm just 0.10 here GCP value, CP value. Then the value will be coming here the positive. Positive when GCPI positive, and here is the GCPI negative. So these are the total value, but if we minus plus, then it will be minus 6.0, and if we sum this, then it will be 3.0. So we have been seeing we are taking the plus minus all these value and found and ultimately found 3.900, which is totally internal pressure, which is windward wall. So windward wall internal pressure, that means it will be upward. So we've been seeing this is the windward wall in the roof. We've been seeing windward roof, and this will be a leeward roof. So as per windward roof, we've been from 3.9, so it will be upward as internal pressure is given here. Okay, so in the same way we're calculating the leeward wall or leeward roof. How we'll calculate? This is the leeward roof. So this is the leeward roof. Okay, so let's see how we'll calculate this below. So if we go to the here, so similarly we've been putting the formula, and similarly GCPI is plus minus 0.50, as we've been seeing here, the plus minus 0.50 first, but changing the CP value. So when the CP is 0.50 as leeward, we can calculate in leeward the leeward below as 0 to 5. If 0 to 5, then CP below is 0.5 minus 0.5, and found this below. So one is positive value and another is negative value. Positive value, that means it will be if we go to the this diagram. So we have been seeing two type of load is applied, is positive and negative. If we go to the outside, into the inside to outside, that will be negative, and outside to inside it will be positive. But I'm just calculating two value in at a time and found minus 1.709. It is the internal pressure. So when we calculate the CP values 0.18 as per our for after calculating here, and with respect to the wall values of L by D, and found 0.18, and found all these values here. One is negative below, another is positive below. So after positive negative calculation, then we have been found 0.604. Now we're just adding two value and found 0.224. This is the total internal pressure. So it will be used leeward roof. So 0.244, and we're just multiply with bay distance. Then we will use this value here. We'll just use value this as per cube per feet. Okay, so we'll just using here cube per feet. So we have been seeing the four value have been found, and just if I am summarizing you that one value number is windward. So this is the windward. I will get this is the windward. So if we see here, sorry, not here. Okay, this is the windward. This is the first value have been found. Second one is leeward, the opposite side of the wall. We've been, if you see the here, sorry, this is the leeward. After you have to multiply with bay distance as it is found kip per meter, but we have been found here kilonewton per meter. And third one we've been seen here the side wall. We've been seen here the side wall is here and here. So where is side wall? This is the side wall, and this is also side wall. So this is the side wall. We've been found the two type of side wall is also this side wall and this side wall will be same. This side wall and this side wall is the same value have been put in here. And another number fourth, the fourth will be leeward, windward, side wall. So now we'll using the roof. So roof we have been divided it 4-1. This is the, we can see 4-1, which is leeward, windward roof. So windward roof is this portion. This portion we can see a windward roof, as this is the wind pressure. So windward roof is we can calculating 4 type, and we just using this value. And this we can see 4-2 value, which is leeward roof. After the calculation we found this value. So this will be leeward roof after all the calculation here. Okay, then similarly we can use the final flowchart we can use here, but we have been found only six load. We have been seen here the windward load. So we have been seen windward, leeward, side wall, two type of side wall, and windward roof and leeward roof. So we have been found windward, leeward, side wall, and windward roof and leeward roof. So in this way we can see here the wind parallel to the ridge. So this is the wind parallel to the ridge, and in previously I have calculated wind is perpendicular, which is called wind normal to the ridge. So now we'll see the wind parallel to the ridge. I will calculate the wind parallel to the ridge. As we know, L by B is 2.27, H by L is 1.20. This is the load question. As we know, the internal pressure positive value and external pressure is negative value. What is internal pressure and what is external pressure? I have already shown here that this is the external pressure and this is the internal pressure. We have already shown here. This diagram will follow a large diagram that this wind direction will be external and internal, the others will be internal forces. This is the inside, this is the outside. You can see here internal and external forces is given from here. Okay, let's see. We just follow this here. Okay, we have been found the velocity pressure at release, which is found here. I will calculate. We already calculating all the pressure and previously. So these are the we have already calculated here. Okay, so let's see. First of all, I'm seeing the windward wall. This is the windward wall we've been seeing here. I think it will be case 2 as we've been using perpendicular to, and after the calculation we've been found 2.390. It will be windward. So I'm just this was the x1, and now we'll calculating x2 and zx. It will be zx. Okay, zx mean it will be parallel to this. So we've been seen here the first load we've been on windward. We just considering and the load will be coming from here. That's what it will be the load 1 windward. After the all calculation, Cp is found 0.80. So Cp is found 0.80 as from here 0.80. As we know, the windward is Cp is 0.80. Leeward, so this is the case 2 we have been seeing here, leeward, and Cp is 0.29. I will calculate. We have been found L by D, so L by D is 2.22. So 2.22, we know the value of 2 is 0.30. If we go to the here, 0.2 is 0.30 and 4 is 0.22, and after the interpolation we will get the value 2.20 is 0.29 by interpolation. So this is the 2.29. We in the previously we have also found and leeward Cp is 0.50. It is also found here, so we don't need to interpolate, but in this case we have to need the interpolate here, and found 0.60. so we are using leeward is here. Sorry, this is the leeward. This is the leeward we have been seeing. This is the leeward we have been using here after calculation here. And number 3 will be sidewall. So what will be sidewall? Sidewall will be like this, and this will be sidewall. As we are considering when load is coming from this parallel to the wrist. This is the parallel to the wrist. That's why the sidewall will be this will be sidewall, and that will be sidewall. Okay, so now we are seeing the rope pressure. As we have been seeing, these are the 4 type of rope will be divided in the 4. We have been seeing the 4 ways as we have been seeing here. So we are putting these 4 0 to h by 2, h by 2 into h into h by 2. So we have been using this formula. And windward rope, we can call this is the 4-1. So windward rope, when Cp is 0.90 and GCpi we have been seen here plus minus, and found these are all the negative value, which is 3.333. And on the other hand, we have been found another which is GCpi is 0.10 after interpolation, 0.10 GCP value. So this is not this is not 0.80. This is not here. We'll found here from after the interpolation of here. Okay, so it is the one is negative, another is positive, and after this calculating we found -6 is So these are minus and these are minus, then total minus will be 0.95 watt. It will be leeward roof. So we'll using this leeward roof here. And we've been calculating the another combination, another load is for to, we can say the leeward roof is here. The calculation is given here, the GCpi plus minus, this is the plus and this is the minus, and CP is 0.50, as we have been know the leeward CP of leeward is 0.50, we have been found here. And although we've been seeing that one is positive and one is negative and other is positive. So after calculating, we've been seeing this is the negative, and another one is using the CP is 0.18, and we have been found the GCP is plus 1, considering that will be negative, and there is a positive value. After calculating, we have been seeing total is negative. So these two are calculating here, then we will found that this is the final negative value, and it will be used in leeward roof. So these are the load we have been seeing. I'm just summarizing. This is the first load we have been seeing here. This is the second load, and this is the third load, and this is the fourth. And this is the fourth, and this is the fifth load we have been used. But you can use segmentally one this load and this load again and again, as per as from this assumption, which is 0 to h by 2 and h by 2 in s and h to s. And you can use and final input value is also here. But I am also making here another Excel for using this here. After the shed length, width of the shed, and height of the eave and ridge height, and angle we have been found calculating, and zone of the Dhaka, wind velocity, and impedance factor induction, and we have been calculating this velocity inflation found 0.101 meter per second, where value of I is given here, I impedance factor is given, directional factor is given, topography factor given, velocity pressure, gas factor, internal factor, and after all the calculation we have been found QZ value is here. So as we know the QZ value here, we're just using this bay distance. What is the bay? And this is the bay distance, one column to another column is the bay distance. If you use this bay distance, then it will be calculating automatically kilonewton per meter, and as per CP value is given here. If we change I'm just changing is 5, then you can see the value is also changed. And if you're using here 5, then you can see this value will be changed. So you just changing the bay distance, then automatically changes. I'm just generating here. So I think it will help you a lot. If you have any question, then let me know. I'm just seeing here the this you can put this value in your own way. You can use this in a way, but you can put these two value in together. But if you want to put this in separately, it's okay. You can put this value separately, but it is taking the so much time, and it will be generate so much load here, as you can see here. There's so much load here. After, if you want to reduce this load, then you can reduce this calculation also. Okay, thank you everyone. If you have any question, then let me know. I'll try to convince you. Thank you everyone.